Okay. Before we begin, any questions? Not only did you not wait for me to ask you to ask for questions, you didn't even have a question. That's very quick thinking on your part. So before we begin, any questions, labs, so on and so forth? I have not yet assigned a homework for this week, but maybe after today we'll have one sent out. If you were in lab today, you know that I made a whoopsie, a boo-boo on the lab. The test file is a bit mucked up. So if you were in the Monday lab, you were very much affected by this. There's a file called .travis.yml.yaml. You'll need to change that from a place where it says lab/ to lab2/. We'll deal with that in labs as we go, or you can come and see me. If push comes to shove, I think that I can, no pun intended, push the solution to you, and Visual Studio will auto-merge it, but I'm not super excited about seeing how well Microsoft has done that just yet. So we'll play it by ear there. All right, methods. Now you've got a question. When you sync it, it'll almost certainly fail. Well, if it fails, fix the Travis file. Okay, so before you submit it for the final time, change it so that it actually runs. Yeah, find me, Keith, or Cameron, or Peter. Yeah, find any of them, but they'll know how to fix it. Or, you can find me. All right. Any other questions before we get started? What's a method? Why do we use methods? And how do we get data back and forth to methods? Everybody know what a method is? It's like you're getting farther and farther away from me, Abe. It's like a function. Strictly speaking, that's not correct. Pardon the metaphor and simile in such close proximity. A method is a function. It's not like a function. Well, of course I did. But like is not the correct word to use in this particular instance. It is a function. Yeah. So you're like a flower in that you brighten my day, but you are not actually a flower. Yeah, I always smile when I get to see you. I can't tell if you're sarcastic. That's part of why I like you. It's a building block. It's a piece of code that we might execute over and over and over again. And it's called from some other places. Now, the things that make functions or methods powerful is the fact that you can give them data to operand on. Maybe you should be teaching the class. All right. So, and it also can give you data back. Now, a classic mathematical function, something like f of x, takes x in as a parameter and returns some y value. Okay? But the idea is if you can break your project down into small, easily digestible chunks, and more important than being easily digestible is easily testable, then you can make a program that's more robust, more able to withstand bad inputs. They're known as functions, procedures, subroutines. All depends on what language you come from. Reasons we just talked about. Avoid repeating code. This is something that I see a lot of students do and have seen them do over the years. They write the same piece of code in 5 different places. And then they realize that they screwed it up. So they go back to those 5 different places and they rewrite that code. And then they miss one. So it doesn't work in one place, but it does work in 4 other places. The idea of a method is to encapsulate that functionality, fun object-oriented programming paradigm word, encapsulate that functionality so that it does it correctly, and then you just call it. In fact, real live life lesson. This is Python, but I think you might see the point. I was just talking about doing something 3 times and then redoing it. I have these 3 functions that I was writing today for something that actually has to work. Parse ISR, parse ESR, parse STB. They all did this over and over and over again. And I finally got sick and tired of copying that function every time I found a new register I needed to decode. And I encapsulated the functionality of parsing out the names of bits into this function called parse generic. What do all these other functions do? They define some data, and they call parse generic. Real life example, does that help or confuse? A little bit of both. The idea is we're giving it some information. In this case, it's an array of information or a dictionary of information about bits. And I have a value. So when I parse this value, all I really do is pass that data on with a little bit of extra data to help it work. Yes?
But you're calling that function in return from the fluid 5500A folder and then pulling that specific.
So parse generic returns result. So I'm returning result from parse generic, and then I'm returning what parse generic returned.
Right. So it's, but what I'm saying is like the fluid 55. That's the location of.
That's the class. This is a static method, so it belongs to the class. Okay. And it's in Python, so let's not go too far down that rabbit hole, huh? I mean, it's a good rabbit hole to go down. If you were going to choose a rabbit hole, you could do worse than Python. But we're doing C#. Okay, how do we do it? In this case, a method consists of a type, maybe an access modifier like static, or public or private, and a return type. So void means no return type in this case. It's the dumbest kind of function. It does one thing, and that's the only thing it does. It doesn't take any data in. It doesn't put any data out. It is important to give your functions good names. For example, let's pick some random function out of the air like getNumber. What should getNumber do? Get a number, meaning a single number. Okay? It should not print numbers. It should not take 3 variables in. It should get a number and return that number. So the name of the method should imply its purpose. The closer you can make your code look to human readable, the more it will be read by humans and understood. We've talked about static variables. We can have static methods as well as instance methods. And if you don't already know that everything is encased in squiggly brackets, you've got bigger problems. It's the method body. Get it? You can't see it. My face is in the way. I didn't come up with this joke, fortunately. It's the method. The method body. All right. Where's my face? It's in the way again. The what? Still don't understand the spaghetti monster, and I'm still happy not understanding the spaghetti monster. Methods, though, must exist inside a class. Okay? Everything in C# is some kind of object. Objects are instances of classes, so every method must belong to some class. When you start a project new in Visual Studio, you're given a default class, some as the name of your project or something. But it must have a class associated with it. In this case, all of these are static methods, meaning that you don't need to instantiate the class called method example in order to call these methods. Calling a method. Any questions? You put parentheses after it, it calls it as a method. Question? Again, we're going to quibble over the word basically. They are actually functions. Methods is just a vocabulary word, okay? In this language, we call them methods. And that's only until I forget that we're in C#, and then I call them functions like everyone else. Okay, it's just a function. If it makes you feel better to think of it as a function, go for it. Just know that when I say method, in my head, I had to stop myself from saying function. No, you should call it a method, because that's what it's called. Because it's a method. It is like a function. Didn't think you were in English class today. It's a method. Synonymous. Okay. These are not interesting methods. I don't care. I'm not going to do... okay, methods with parameters, though, that's more interesting. Because methods that just do one thing and don't allow you to provide any input to it aren't that interesting. I forgot to open this before we started. Ooh, there's an example called data validation. You want to guess what's going to be inside of it? Guys. Yes, Trevor. No, those are modifiers. There's two types of methods, static and instance. Then there are access modifiers, public, private, and internal, which we don't have to talk about yet. You'll notice, by the way, that if you look at any of the code that I've provided to you in the GitHub repositories, all static methods have been declared public. At least I hope they have. I'm pretty sure they have. The reason they're public is so that I can call them from the test project, because it makes them accessible to other things. Okay, so methods with parameters, they take a parameter, which is like an argument. Thank you. Thank you. Those are two words for the same thing, an argument or a parameter. So here there is an integer parameter. And in this case, what is it doing? What is print sign going to do? It's going to print the sign. In this case, either positive, negative, or 0. What do you think print max is going to do? I won't even show you the code. It's going to print the max of what? Of what? Number 1 and number 2. Whichever one is larger. Let's see. Oh, look. It prints the largest number. What arguments does main take? None. It doesn't take any arguments. Okay, so what does this program do? It asks for two numbers. It uses the unsafe int.parse. So if I were to type Bob, that would have a problem. But for the example, it's pretty straightforward. Which, of course, has nothing to do with what I just ran. Okay, two numbers, say 10 and 200. The number 10 is positive, the number 200 is positive, and the big one is 200. Nothing earth-shattering, but the point is, in order to generate these statements, I didn't have to write the code twice. I wrote one method that knows how to figure out if something is positive or negative, and I called it twice. Calling is what happens when you transfer control to a function. So when you actually run this, it's going to run this code twice, once for the first number, once for the second number. But it's only going to take up this much space in the program memory. How many of you are in 263? Or anybody not in 263 at the same time as this course? Better question, not in 263 now and haven't taken 263. Really? Freshmen are taking 264? Huh. Oh, I know. Plus a few grades that don't exist. What do you? 13th, 14th, 15th, 16th. Is there an 18th grade in there? You don't have to volunteer that information. Okay. So when you pass in a parameter or an argument, it makes a copy of the data and sends it in. This is an important feature. You pass in a copy of the data. You don't pass in the data itself. So if I go back to this here for a second, print sign passes in number. I could put in some bad code here. Number equals negative or minus equals 50. Okay? Nothing syntactically wrong with that statement, although now I've broken the principle of a function should only do what it says it's going to do. If I run this, 50, 100, it doesn't print 50 and 100 anymore. It prints 0 and 50 because I modified it inside the function. Come back to main, though. Printing the max of n and m does not get changed. The maximum number is 100. Because when I call these functions, these methods, right, I pass a copy of n. So whatever was inside n gets copied. That's in the function. That's what gets modified. The original n is fine. It's unmolested. It stays the same. So when I call print max, n and m, 50 and 100 again get copied into those two, into that function. That's an important feature of a method. It copies the data in. Where things get more interesting is we have two variable types. We have, it's gone. Two variable types, sure, absolutely. We have value types and reference types. Did you just throw that at me? Thank you, I caught it. Value types and reference types. A reference type is a reference to larger amounts of data on the heap. And when you copy a reference type, you copy the reference. You don't copy all of the stuff on the heap. So you have to be a little careful when you pass information to variables and it's a reference type. A lot of times people forget that that's the case because a lot of reference types are immutable. What does immutable mean? Can't be changed. Yes. Well, we could make an example, right? So let's quickly. Actually, do I have a quick example here? Quicker than me writing it. Month. Start month, end month. This is all, again, this is all integers. Month name. Oh, I like month name. But that's all I got. Okay, we're going to have to write our own. So, for example, string we have a string. And this isn't Python, so we need double quotes. Okay, this string is a reference type. Ouagadougou, yes, is a reference type. Okay, Ouagadougou is allocated on the heap. Name is on the stack. It references the heap. if I made a method that takes a string right, Bob, and then print that string. Perfectly reasonable function. All of this compiles. So all I have to do is actually call this temp name. And it would help if I did the right one. Did I forget a semicolon? Thank you. Wagadoo Bob. Say that 3 times fast. Well done. Well played. It works. The question is, what happens after I call it? If I do a console write line of name, about them paths. Whoa. Oh. Because it's still open. Close all windows. Wondering why it was taking so long. Ah! Magic has occurred. So when I printed it inside the function, it was Wagadoo Bob. Once I came back from the function, it was still Wagadoo. Even though it's a reference type, it's immutable. So the key here is this line right here creates a whole brand spanking new object. And S becomes a reference that points to a new thing on the heap. So this is one of the ways that it kind of works against people who are just starting out in C#. It looks like everything is a reference type, but then you get things like this, or it looks like everything is a value type, but you get things like this where it's not doing what you would expect because it's immutable. If we had a mutable thing on the heap, like a list, we did talk about lists last time, okay, then things begin to get strange. So let's do it. A list of ints, not ints, just int. 1, 2, 3, 4, 5. More than happy to do that. We can create another method. That takes a list of ints. Good. And we can print that information for each. Actually, we're going to call this one print list because we need to sort of demonstrate what's going on here. Print list. For each int I in B, console.write squiggly 0 space comma I. Why are you yelling at me about? Yes, it does. Ah. You happier now? Or is it list collections generic? List collections generic. Okay. In order to use list, we have to make sure that we put it in that it's in the right namespace, which is system.collection.generic. All the generic collections live in this namespace. So it was just yelling at me because it didn't exist. Okay. So here I've got for each integer I in the list B printed out. And at the end, put a new line in it. So we can quickly take this list Bob and say print list, even if we don't know how to spell. But apparently you do need to know how to type. Print list Bob. This is going to pass the reference of Bob, and we should see 1, 2, 3, 4, 5. Especially if we close the old one. Okay. Nice, simple function, does one thing, it prints the list. Now we're going to write another function. Okay, mod list. And what mod list is going to do is say b dot nope, still not in Python. No, I've just been coding in Python all day. Add 100. We're not returning any values out of this. So we're going to print list Bob. We're going to mod list Bob. What about Bob? And we're going to print Bob again. And we're going to close the old one. So, passing reference types around is a bit of a problem. When we pass a reference, it changes on the heap. And anything that happens on the heap stays on the heap. Okay? So even though we have not returned any information, notice that it's a void function. Things are still changing. That was a very long example. But I think it was worth it to talk about it. So we have two types of variables. What are the types of variables? Value and reference. We also have two different types, mutable and immutable types. If you have immutable types, they act like value types when you pass them to functions. But value types copy the entire information and send it across. When you have reference types, you can have unintended side effects. So reference types passed to functions have side effects. Okay. Yes, method's behavior depends on its parameters. You can have as many as you want. I don't think we need to go through calling these things. We've done quite a few examples here. I'm not interested in this example. This does look interesting, but is not how it's supposed to be tabulated. This is supposed to be two different triangles. And you've all done the stars lab at one point or another. I don't think we need to look at this. Although, if you had had a method that would print a particular number of stars or a particular number of spaces, that would have helped a bit in that project. Okay. This is where magic begins to happen. Default or optional parameters let's say 9 times out of 10, you're going to call a function and the number is going to be the same. Or sometimes you just don't care about a particular variable. You can give default values, and that makes the parameters optional. So this function, what does it do? It prints numbers starting with a start value, ending with an end value. So if you give it 1, 10, it will print the numbers 1 through 10, inclusive. We've given it default parameters just by saying int start, which is how you normally declare something, equals 0. I did just notice a typo here. This is not supposed to be a semicolon. This is just supposed to be a comma. That's not a new thing in C#, that's just a typo. Is that in the other example too? In the for statement, that's where it's supposed to be semicolons. That's standard. But this is supposed to be a comma. So let's look at it here. This is correct. So this is a function that you need to provide 2 arguments to. If you don't, it won't compile. Here, this has default values. So if you fail to provide a parameter, it will try to fill in the blanks. So you can still use 2 parameters. So print number 5, 10 will print 5, 6, 7, 8, 9, 10. If you pass only 1 parameter, it decides to fill in starting at the left. So the 15 becomes start. End takes on its default value. So this will print 15, 16, 17, blah, 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 100. If you give no parameters when you call this function, it will use the default for both. In this case, 0 to 100. If you want to get crafty, you can use named stuff. Now, this is C# 4.0, I think. I'm not sure if .NET Core allows this. We could check easy enough. But you can provide a name for the argument, and this allows you to swap the order of arguments to fit your need at the particular time. And this is, in fact, the only way that you can use the default value for start, but not the default value for end. When you have multiple default arguments, the only way to use some but not all, if it's not in the order you want, is to use these named arguments. So you just put the name of the argument, start or end, followed by a colon. And then you put whatever the value is you want for that. We'll do the optional parameters. So here we have something with default parameters. Here we've changed it to be 0 and 20. That doesn't look like what I wanted. There we go. So each row corresponds to 1 call. In the first case, we use it in a traditional sense. We give it 2 arguments, and it goes from 5 to 10. In the second case, it does start at 15. When we give it nothing, it uses 2 default values. The default values defined up above, 0 to 20. Then the last 2 used named arguments. We pass it end and start. Just to show that you can, we swapped the order. So up until now, the only way you can do methods is with positional arguments. The first thing you give goes to the first variable. The second thing you give goes to the second variable. But now we can use named arguments just by giving it the name. So if we only want to provide end, we can. And so here, end is overriding the default value of 20 with 10, but we use the default value of start, which is 0. So we go 0 to 10. Now, in these toy examples, it's not really clear why you would want to do that. But I think when I set it up to begin with, there are a lot of times where we have default values that we want to do things most of the time, and then sometimes we need to override that behavior. Oh, do I not have any of those? I thought I had a few default value cases. In some of these, but I guess not. Okay, moving right along. Okay, how do we get stuff back from a function? I think all of you are familiar with the return keyword. Return takes data from the function and makes a copy and sends it back. Again, that copy can be problematic for all the reasons we've talked about. Depends on if it's a reference type or a value type. If it's a value type, it makes a copy of the value and sends that back. If it's a reference type, it makes a copy of the reference and sends it back. Question? No. If you have a method that returns a value, you can use it because the call to the function evaluates as what it returns as. Okay, console.readline is a method that returns a string. So you can use it in an expression like message equals console.readline. There's nothing wrong with that. You could also have said string message equals quotes hello, because hello is a string literal, it evaluates to a string. You can also chain things, and I do. This is my shorthand all the time. If I'm doing something where I don't have to worry about parsing the input, validating it, you can say int.parse console.readline, and it'll do it all in one line. Of course, it will also crash and burn if you type in Bob, but if you're just trying to get something done quickly, you can start there. So chaining inside of things is okay, but if there's an error at any point in that chain, it'll be harder to debug. Okay, so the only trick is we have to specify the return type. Int, float, double, list, all of those are valid return types. Anything that is an object can be a return type. No matter how complex or large, we can return. We can still only return one value. One. Yes? Could you return a call to another method? Not in the way in the way you're asking, I think the answer is yes, but you cannot return a call. But let's just pop over to what we were doing before. From earlier on, this parse generic. Parse generic, in this case, it returns an array. It's an object. It returns an object. Now, when I come up to one of these other parse routines, I am returning not the call to the method. I am returning what that method returned to me. So in the main program calls parse QSR. Parse QSR calls parse generic. Parse generic returns an array. QSR returns that same array back to main. So when you say, can I return a call, were you asking, can you do something like this? You're returning what that method evaluates as. You can only return objects. Okay. Void methods, which is what we've used so far, technically don't have a return value. You can still use the return statement. You just can't put anything after it. Okay, now there is a bit of a problem in the book. It does not cover one aspect of C#. It's kind of more detailed. You can only return one. You cannot return multiple. You can't in C either. We have a way around it in C, though. Whatever you do in C. Right, there was some stuff about pointers. We've actually already used a function that breaks that rule, that returns more than one variable. What method? Try parse somehow gives us two pieces of information. Okay. Okay. So when you want to return more than one thing, multiple values, there is a straightforward way to get more than one value out of a function. And it's using the out keyword. Okay. If you make a method, void my method, takes in some variable int x, that method all by itself is just a method like we've always seen. If we want to return a value, what would we have to do? Where is my cursor? We could change the result, the return type, to be an int. And then inside of this method, we could say return 5. Okay, or maybe let's make it more interesting, 5 times x. Okay, return 5 times x. But if we want more than one return value, we need to declare additional parameters to the method.
So does out in essence then, or is in there also kick that out? Is that what out means?
It means that any change made to y inside the function is reflected in the function that called it. So, other than that though, everything looks okay. Yes?
Is there any reason you could put static?
Because I got lazy. And it's not required. It's not part of this example. This could be an instance method. Okay? And, okay, there we are. So you could say y equals 5 times x. And that would result in y being whatever 5 times x is in the main function when you return. This is a void function. We're still getting data out of it. Question?
In order to turn on the light, you have to initialize it. Or you can declare a library beforehand.
It's up here. Is my writing not clear? That's out int y.
Will that come back to the eventually?
Yes. So let's say, how would you call this inside of main? Int Bob. My method 10 comma out Bob. And that's important. We have to use out in both places. We can't just say Bob. We have to say out Bob. Fortunately, we'll get a very descriptive compiler error saying you need out. Question? Why? Because I picked 10 out of a hat. So what's this going to do? What will Bob be when the function returns? That's right. It's positional. Okay. So it'll return 50. Bob will be 50. Now, something that's not intuitively obvious. Before I call the function, let me ask one question before you ask yours. Before I call the function, what is the value of Bob? It's uninitialized. And that's key. If I tried to pass Bob to a function without using out, I would get an error saying it's uninitialized. But without, I can pass uninitialized things into a method if they get initialized in the method. Okay? Well, int Bob, that's declaring it. Declaring it doesn't actually allocate the space. It's just, okay, there's a thing called Bob, but it doesn't have any data. Yeah, if I had said equals new int, then it at least would have been initialized. okay, with 0. The default value for an int is 0. But this is an int that has not been initialized. As a result, if I had tried to use it, say Bob plus equals 1, that wouldn't work because you can't add 1 to uninitialized. It does not compute. Okay?
So at this point, if you did underneath this Bob plus 3, would it still be okay?
Underneath my method? Yes, it would, because you'd get 53. Okay? Because inside the method, it's been initialized. It's using an alias, y. So inside the method, it thinks of it as y. Outside the method, it's Bob. Okay? So that's another key piece of information. You get an alias inside. Okay, questions on that? Yes?
How many do you have?
Oh, I think there might be an upper limit, like hundreds. I have never bothered looking up how many methods, because in practice, you can have hundreds. In reality, if you have more than, say, 7 arguments, you probably should be splitting that function up into smaller chunks. Okay? There's a rule of thumb, I forget who came up with it. It says humans, as a general rule, can keep track of 7 things in their brain at once. Once you add that 8th thing, you start missing, like the whole house of cards falls down. You suddenly can't remember any of them. Okay? So as a programmer, if you're going to be reading your code ever again, or you're going to be giving this to someone who's going to read your code, you want to keep it manageable. So if best you can do is 7 things, derate that by about 20%. Okay, do 5 variables at most. There was one program that used to happen in 160 that was carpet or something. You had to pass in like 18,000 variables just to show that you could. It was a pain because you can't keep track of that many things in your head. Now, this is not the only parameter modifier. We also have things like ref. Okay. Out is a little more common. And again, if you want to know more about these, I encourage you to go to the .NET Core documentation. There's a very eloquent write-up on these. But for what you need to know for this course, how do you get data out of a function? You use the keyword out. Okay. Now, page down. Where does function page down? Okay. So your homework will probably involve both arrays and methods. You'll have to be a little careful. If I'm asking you to write methods, I'm already going to have to know what that method looks like, so I'll have to give you the method stub, and so that I can test that method. You can't just call it whatever you want. Okay? So look for that probably sometime tomorrow or the day after for a homework assignment. Sometime. Okay, questions before I stop recording?